and 2 while we talk, you totally can. If you just want to listen and be like, well, I'll find more practice that I won't hear the answers to before I practice, that's okay as well. Question number 1. What do we got? Any questions? Did we go over this yesterday? Questions? Yeah.
When we went over part B yesterday,
yeah.
was it recorded?
I don't think so. Do you want me to go over it now? P.S. If you're totally bored, you could be grabbing out your When You See You Think, because that's due fully attempted and ready to go for any last-minute questions or AP tips on Thursday. Remember, our Forever Endeavor final is on Friday. And remember, the last chance for any bonus practice exams is on Monday. Our homework, for those of you that were absent yesterday, is not to finish these 2017 FRQs. We are taking 12 to 13 minutes in class and then looking at the answer scoring guidelines, and then taking another 12 or 13 minutes in class and then looking at the answer scoring guidelines. We're giving you that pressure, that time component aspect of FRQs and what dilemmas, what weaknesses it will bring out in you for you to work on for the AP. So the 2017 is not homework. The homework was to have it graded for today, the 2 that we did yesterday, and then to go over questions. But the homework is your bonus practice exams, studying your Forever's Endeavors, and your When You See You Think. Cool? Cool. Okay, so then coming back here, Brendan was just asking about letter D. That was the weird volume-y one, where we were trying to, actually is a related rates one, just in a very creative, interesting way. Let me grab the question up really quickly. I think I have it right here. Question number 1, letter D. Water is pumped into the tank when the height of the water is 5 feet. So we had to such that. Okay, we had such that h equals 5. We gave us, or it gave us that dH dt. Height is increasing at a rate of, is it 0.26? Kiddo, sorry, it's kind of small. 0.2. No, isn't there? Okay. And then we're trying to find the rate at which the volume is, so we're trying to find dV dt. We don't actually have a given formula for volume, but if we remember back, if they're talking about cross-sectional areas, that's this problem, right? Cross-section? Yeah. Volume with cross-sectional areas, remember, it's the integral of the cross-sectional area formula. So then we went ahead and said, oh, well, if it's the integral of the cross-sectional area formula, in letter C, they told us this f of h is the cross-sectional area formula. So we could go ahead and say, okay, so a volume could be an integral from, did they give us an initial point, a range? Is it starting at 0? Well, that's the when. That's the such that. We can just go from 0. Starting at a base height. Is the water filling the tank? Is that what's going on? Okay, so then it's going to start with the water level being at 0. I was seeing if there was an initial level, sorry. With the water starting at 0 and then going to some time t. Oh, it's in terms of h. Thank you, thank you, thank you. No, h is what's in the integral, right? No, we need to take a derivative. We don't want to go 0 to 5. That would be a constant, and the derivative of any constant is 0. That's not going to be helpful. I'm going to put my f of h in because that's my function. Oh, that's what we did yesterday. We made it f of t, didn't we? Okay, thank you, thank you, thank you. So we made it f of t with dt. We can use that exact same formula. Then now we can incorporate the h because it's from 0 to whatever level we're at. Sorry, I had to remember what was going on. Water, tank, height, filling, k. The problem is right here, if we were to take a derivative so that we could use FTC part 2, we would actually need to take ddh at both sides. So we could say dv dh is equal to f of h, f of u times u prime, and that'd be dh dh, which is fine. But then I also need to get to dt, so to do that, I could multiply this side times dh dt. I could multiply this side times dh dt. That's one way of doing it. Another way of it is that you could actually, if you want to think about it this way, you could take ddt of both sides. That's kind of more what most of us would think of doing, taking ddt of both sides. ddt of this side would be dv dt. ddt of this side, sadly the t and the h don't measure up, so we could go ahead and do our f of h, but then we would have to do times h prime, and times h prime would be your dh dt. So you could kind of think of it like that. That might be easier or simpler than what we were showing yesterday. But at this point, all we have to do is plug in our givens. So plug in 5 to f of h, plug in 0.26 to as dh dt, and then you guys know, stick it to the man, don't you dare simplify. Why waste time plugging in it? And so it's f of 5 times 0.26. I mean, if you have your function already in your calculator, then I guess maybe getting the decimal would be the simplest way to go. If you don't have your function already in your calculator, I would just write out the, I apologize, it's small, 50.3 over e to the 0.2 times 5 plus 5, whatever that should be. Whatever that should be. Brendan, is that good? Yeah. It technically says to also, I think, does it say explain or interpret using the find the... Well, units of measure would just be feet cubed per minute. They went ahead and interpreted it a little bit in the sense of the volume is increasing at a rate of or changing at a rate of. So they were doing a little bit of interpretation, but I don't actually see that in the question itself. And we can look at the points really fast, but I think it was just the answer with the units. They weren't necessarily forcing you to say changing at a rate of or increasing at a rate of. You could have just said dv dt. Yeah, Katrina. Perfect. Volume, time. Well, they did the entire FRQ and they graded the whole thing. I'm just going over questions. So if you have a question. Okay. C is saying find the volume. So that comes back to what I was saying a little bit ago about the volume with cross sections. All you have to do is throw the area in. So if it was a square, side squared. If it was a rectangle, base times height. If it's given to me as a really funky, weird function, sweet, I'm going to throw it in the integral. I'm going to start at 0, which is no water, and I'm going to go all the way up to the whole tank, 10 feet. Because my bounds need to be h's, h bounds. Integration does not change? No, because I'm trying to find the volume, and you have to think of how, guys, this is a good visualization for everyone for cross sections. How does volume by cross sections, or even discs and washers, how does it work? You start at the beginning of the shape and you accumulate through the end of the shape. There is no having to add an initial condition or anything like that, a final initial. It's just saying, no, start at the beginning and accumulate, add up all the slices infinitesimally thin until the end of the shape. And so that's what's going on here. So you're starting at the base of the shape, which is 0, up to the top of the shape, which is h equals 10. And I'm doing everything in terms of h because that's the function they gave me. Is that cool? So you would end up with the integral from 0 to 10 of f of h dh. Okay. Any other questions on number 1? With the grading, with the questions, with the answering? Going once, going twice? Sold. Let's go ahead and go look at number 2. You guys also had this. You were trying this at the very end of class, and I'm pretty sure that I gave you the answer key right at the end, told you to take a picture. Told you to take a picture, and then go ahead and grade. I'm going to go ahead and make the answer key really big real quick because some of you guys are still trying to figure out the grading on that. No, I think we're good, Cameron. Thank you. I appreciate it. Does anybody have a question right now that they want to ask while some people are still grading number 2? Yeah, Corey. C and D. Okay. C, it was all about the wording. C was all about the wording. They asked for the distance between 2 polar points on 2 separate polar curves, right? So you could think of it 2 different ways. John, this is the one you and I were talking about, right? The distance between the 2. Okay. If you look at the points they gave you f of theta, which is an r, and then they gave you g of theta. Here's my question. Aren't these both on the exact same line? The same radial line, the same angle line. which means it's really as simple as on a certain angle line saying, oh, hey, here's the F, and oh, hey, here's the G, because that's the R. So we would have one, we'd have the other. So it is as simple, the distance between them is as simple as just subtracting them. However, if you don't like that answer, there is another way to think about it. You could have also just done the distance formula and done x2 minus x1, which would have been your g of theta minus f of theta, plus your y2 minus y1. That would have been 0. That would have canceled out. You would have had the exact same thing if they were on different angles. But since they both were using a set theta and the same theta, that wasn't like theta and theta plus 2 or theta and 3 theta minus 4 or theta and theta squared plus 1. Like they're the same theta, so they're on the same angle line. So literally you have this radius and that radius, subtract the two to get their distance. I think G, just by looking at it, I think G is farther away than F, so that's why you're able to say G minus F and not F minus G. But then at that point, once you figure out this, like what W equals, then to find the average of W, just think 1 over B minus A, so 1 over pi over 2 minus 0 times the integral from 0 to pi over 2 of W, who is just G minus F, and plug and chug it to your calculator. Does that make sense? Does anybody else need me to explain that because you weren't quite caught up? They were both on theta. You had F that went a certain distance, G that went a further distance. You literally just had to subtract the two radii. But you could have used the distance formula as well. You could have used the distance formula as well. I'm not sure if I can say you can always use the distance formula. I think it just happened on this one because they're both on the same radial line. So the visualization is better. Yeah?
For B, I know.
Everybody's here. Katrina. Huh?
I saw it was different.
Oh.
Can you explain B?
Yeah. Let me get the question up real fast so I can compare. It's going to get small, and I apologize for that. You guys like how the PDFs have it for like visually impaired people, like the entire graph? Anyway, it's pretty spiffy. The ray, theta, is that equals k or minus k? Sorry. Okay. So it's a particular radial line. They call it ray. Interesting. Where k is between 0 and 2 pi. So for some angle in between 0 to 2 pi, the region S is divided into two regions of equal area. Write but do not evaluate an equation involving one or more integrals whose solution gives the value of k. So some way of solving for k where k is the only unknown. It just says S, right? It says nothing about R. It just says S. Okay. S is bounded by, I have to go back earlier in the polar curves, R equals and R equals. Which one's the outer, which one's the inner from you guys graphing? It's a graphing calculator one. Okay, G is the outer, F is the inner? Bounded by the curve R equals F of theta, the curve R equals G of theta. Wait, no. R is bounded by F. Yeah. S is bounded by G. No. Let S be the... Oh, no. S is in between. S is not the full thing, huh? Oh, okay. That's good to know. Bounded by the curve F and G. Okay, so if S is... Sorry, I was thinking S was the whole thing. So F is just the... Or S is just the in-between. So because we're doing the in-between, we have to think of our polar area equation, so 1/2 r squared. But we have to think of between, so going out the S, subtracting the r, so that's going to be our 1/2 outer radius squared minus inner radius squared. So that's where they get the g squared minus f squared. Technically, the formula for S in general would be 1/2, right? Like this would be S if I was just finding S. But then we have to go ahead and figure out where this could cut in half. So cutting in half, they went ahead and said, okay, what if we just go ahead and go from 0 to k, which I would have done this a little different. 0 to k is going to equal half of the whole s. There we go. So half of it from 0 to k is going to equal half of the whole s. There we go. So this would have been my expression for 1/2 s. But what they did is they're like, well, wait a minute, both sides are going to have the 1/2, so they went ahead and canceled out the 1/2. Like both of them have 1/2 r squared. So that's how the 1/2 just disappeared, which you wouldn't have had to do, but you could. So you can say, okay, what's left is the 0 to k being 1/2 of the remaining portion of s. And that's enough, because this you could solve if you needed to. And then all you're missing is k, so this would solve for the k. Kyle, go ahead.
Where I showed it,
Mm-hmm.
I don't know if I didn't give myself a point for this, but
Okay.
I said that expression from 0
Which
to
expression?
0 to k.
Okay, without a 1/2?
Well, that's wrong. And then I said it equal to s over 2, but I can't say s right now.
Because you needed a 1/2 in front if you were to do that.
So if I say s before,
That
because I use
No, because the 1/2 would multiply over and cancel out, so you just made it even worse. Because you need the 1/2 r squared in the area formula over here. So if you're getting rid of the 1/2, that's multiplying by 2, not dividing by 2. So that'd be 1s. Mm-hmm. Which is why I was trying to show you my notation, because I would use the area formula. I wouldn't go super crazy. So I agree with your s over 2, which is totally fine, but the problem is s over 2 would end up being 1/4. You're right, but you would still need the 1/2 over there. Does that make sense?
So if I didn't show the 1/2 and I put s.
If you put in equals with s over 2, you need the 1/2 with your 0 to k.
But if I wait, so for this question, if I use, I'm just asking for in general.
Mm-hmm.
If they ask for a problem like this, if I set it equal to s, do I get points for that? If I do it correctly.
If you set equal to s, we
If
do
I
it
use-
correctly. If you use the letter s,
Yeah.
have they defined s? No, that wouldn't be points. Well, I mean, it wouldn't be points for the full expression. Hold on, let's see what they gave you points for. Sorry, no.
I didn't give myself points for that equation.
They wouldn't give you points for the integral expression, but they might have given you points for the equation as long as you did it appropriately. Does that make sense? Yeah. But the problem is with the weight, it wouldn't have been. But. Katrina, that made sense?
Yeah.
Okay, anything else on number 2, Corey?
Oh,
So part C, we made the average W of A. They're asking for when W of theta is equal to W of A. We just talked about W of theta, how it equals G minus F. So we would take G minus F. We would set it equal to 0.485446. We would find the intersection. Right, because we're trying to figure out when it happens, find the value of theta when it happens. So we could find the intersection of those two, or we could subtract this to the other side and then find the 0, right? So we're setting that equal to that using our graphing calculator to solve for this. Is that okay? Whether intersection or 0. And once we have that theta, then it says, is the function w of theta increasing or decreasing? Wait, calc AB, increasing or decreasing? We're going to derive w. How do we derive w? Can't we do an n derive on our calculator at a point? So we're going to do n derive with what? With g minus f at what point? At 0.518. When we do that, you can figure out that it's going to be negative. They didn't even state the negative in case they were wrong. Hey, look at those sneaky little stinkers. And then they figured out, oh, okay, cool. W is decreasing. Now, okay, I was looking at letter D. Pause, looking at letter D. If you had no idea how to solve, you guys know increasing, decreasing. Couldn't you have just made up an answer for w prime of theta and then been like, oh, hey, cool, based on that answer, no idea how I got it. W is increasing at because it's positive, or W is decreasing at because it's negative? Hey, that could have gotten you a point. No, but you could have gotten the point, because if you had an incorrect and then you used it correctly, they could have given you this point. They just wouldn't have given you that point. Anyway. Yeah.
Can I explain what I just did?
For D?
No, for B.
Okay.
I'm going to that okay.
Yeah.
Okay, so I did 1/2 from 0 to K, G, and then I subtracted that from 1/2 from 0
Wait, not squared?
squared,
Okay.
and then minus 1/2 from K to pi over 2 F squared.
Ooh,
No.
Problem is, for the entire interval, 0 to pi over 2, you had two curves you were working with, so you need both of their bounds to be the same. Does that make sense? Yeah.
How can you square each individual function on the whole quantities? Because I know the formula for polar is 1/2 the integrals of the thing squared. But why do you split up the squares?
You have to think back to your forever card, how we were doing area between. An area between, it's outer radius squared minus inner radius squared. Think something similar to washers, how we had to deal with them totally separately and put them together.
Okay.
Yeah. All right, kiddos, with that. Whew. We only have time for one more FRQ, and it is what it is. Hopefully everyone's all caught up. Shh. Complete silence. Calculators put away. Number 3, I want you guys to go ahead and take 12 minutes. Ready, set, and go. I'll show you the answer key in 12. Some of you are already working on it. Did we do this yesterday, number 3? Oh, you guys were just bored. Oh, well. Try to catch you up, and then it just doesn't work. Okay, pause. Number 3 is an AB FRQ. You guys saw it last year, true? Can I make number 3 homework tonight for you guys to try? Everyone go to number 4. It is, but it's one that most of you failed at, so go. Go. You already did 4 too?
Potato problem mistake.
It's because I accidentally, you told me to do number 1 and 2.
Homework.
I did do it.
Oh, you already had it graded. Wait, why are we talking? You have 12 minutes. Go, potato problem. Let's see if you can do it this year. It's not about the potato. Who cares? It's about the math. Focus. Take a picture of number 3 to grade tonight. All right, number 4. Here we go. Everybody have number 3? We're good?
Really good. Really bad.
Good, Alan?
This is bad.
What's bad?
I did a lot of math. I did a lot of correct math. But I don't think this correct.
All right, there it is. Grade it.
Wait, did we have to get negative 16?
We didn't have to simplify. You didn't have to simplify. But do you have a correct expression? Is this there? Is the 91 moved over? Okay, then you're fine. Remember, you're not supposed to simplify. Because you have to approximate. You had to move it. It didn't say tangent line. It said use a tangent line. But pause. You get 2. You just wouldn't get the 3. You had to move the 91. You didn't have to simplify. You had to move the 91. Because it says to approximate the function value. So you need the y by itself.
What if you did that when you approximated, like right at the
Did you eventually have the 91 plus?
I left the tangent line like that, and then when I approximated.
Oh, wait, that's still part A, though, right?
Yeah, I just.
Oh, no, that's okay. You moved the 91.
Yeah.
Yeah, you moved the 91.
That's fine.
Yeah.
Solving it, move it over. Y by itself.
Did you simplify wrong?
No, it's all the right answer.
Oh, then you're okay. Then you're okay. Letter, which one? I think so. Because 91 minus... Wait, why 3/4?
I hate myself.
No. The tangent line was at 0. So the 3 only affects what you plug in for h. So only affects the 91. Does that make sense? So I use 91. I use the 0. So I need the 0. So wait. No. I have to use 0 for my tangent line. So this is the tangent line. I only change this one when I think about 3. Does that make sense? Yeah. What?
For B,
Yeah.
if I just solved for d squared, the second derivative, and then I got a negative number, so I said therefore it's an under approximate.
Got a negative number for the second derivative?
Yeah.
Did it say justify or explain?
It says with reason.
With reason. But the instructions just say determine whether your answer part is an underestimate or an overestimate. No, but
Does it say to find the second derivative in any way, shape, or form?
Use the second derivative to determine.
And you just showed, like, you just had a negative number, and so you said therefore? I would give yourself the point, but I would make a note. No. I'm not the AP graders, so you need to change that for the AP. You need to actually say H double prime is, therefore H is, therefore underestimate. If you're doing a tangent line, a line always skims a curve in an opposite fashion. So concave up, the line's going to be skimming below. Concave down, skimming above. So the sign of your second derivative of whatever you're trying to do a tangent line to will show you the under, over. Just you need to state why in the sense of like, oh, concave up, therefore. Concave down, therefore. Not it, but H, but yeah. You guys have a picture of number 3 to grade tonight, and if you haven't done number 3, you're going to have it done for me tomorrow. Nobody touch 5 or 6, hopefully, so that we can do those BC. I'm done. Anyway, our goal tomorrow is to do 5 and 6, to grade 5 and 6, to go over questions to 5 and 6 before the class is done. What's due Thursday? When you see you think we'll go over questions Thursday, AP tips on Thursday, places will try to trick you Thursday. What's on Friday?
Wait.
The Forever Endeavor Final. What's due Monday? All the extra credit that you could possibly do. So what's your homework? Study your Forever's Endeavors, finish your When You Think, and print out practice exams. Yes, please. Yes, please. Yeah. After the AP, I'm guessing. Any logistics lowest score form to replace? No. Yeah. After the AP. After the AP. We'll see.